Welcome to this video lecture on the topic log periodic antenna. So log periodic antenna, often called as LPDA, is a wideband directional antenna that provides gain and directivity combined over wide band of frequencies. So log periodic antenna, in which impedance is logarithmically periodic function of a frequency. So the geometry of antenna is chosen that electrical properties repeat periodically with log of frequency. The frequency range around 30 MHz to 3 GHz, which belong to VHF and UHF bands. So log periodic dipole array consists of number of dipole elements progressively reduced in size from back to the front. The direction of maximum radiation is from the smaller front as shown in this diagram. The active region, the sections of antenna that are contributing to the transmission or reception vary with frequency. Then only about 3 maybe really contribute to the radiation at a given frequency. There is also a smooth transition of the active region of LPDA along the array as the frequency of operation changes. Each dipole element of LPDA is fed, but the phase is reversed between adjacent dipole elements. This ensures that the signal phasing is correct between the different elements. It also means that feeder is required along the length of the antenna. So normally this is arranged, it forms part of the mechanical structure of the array. Working of LPDA, when the signal meets the first elements on the antenna, that is those closest to the front that are the smallest, it will be found that they are spaced close together in terms of operating wavelength. As the feeder sense is reversed between the elements, the field from the elements will tend to cancel and no radiation will occur from these elements. As the RF signal travels along the feeder in the antenna, it reaches a point where the feeder reversal and the distance between the elements gives a total phase shift of about 360 degree. At this point, the effect which is seen is that of the two phased dipoles. The signal from adjacent dipoles in phase. The region in which this occurs is called the active region of log periodic antenna. Although the example of only two dipoles is given, in reality the active region consists of more elements. The actual number depends upon the angle alpha and design constant. Behind the active region, the signal again falls out of phase and no radiation occurs. The elements outside the active region receive little direct power. So the design equations of log periodic array. So log periodic dipole array consists of sequence of side-by-side parallel linear dipole forming a coplanar array. So it is given by the equation using the gap spacing of antenna, and also the spacing factor is defined by sigma, where r is the distance of dipole from the origin. And the design equations for log periodic array is defined using the dipole length increases along the antenna so that the included angle is constant, and the length and spacing of elements are scaled like this using the constant k. So next is the apex angle and scale factor equations. So here the apex angle is given by 2 tan inverse of 1 minus tau by 4 sigma. So it is derived using the spacing factor and length of the dipole antenna. So from this frequency ratio, our bandwidth is given by Ln plus 1 by L1 is equal to k power n. So for the optimum design, k value is 1.19. So for this, the ratio of L5 by L1 is equal to 2. So hence, for 5 elements dipole array, we have taken 5 elements and k equal to 1.19, and the frequency ratio is 2:1. The element 5 is twice the length of the element 1. So the design of LPDA involves the determination of spacing factor sigma and scale factor 1 by k. The spacing factor gives the successive dipole spacing, and the scale factor determines the length of the successive dipoles forming a wedge-shaped cone. Advantages: the antenna design is compact, gain and radiation pattern are varied according to the requirements, and disadvantages are external mount and installation cost is high. Applications of log periodic array. It is used for high frequency communications and TV reception and all round monitoring in high frequency bands. So these are the assessment questions. Log periodic array uses which range of frequencies? The answer is option A, VHF and UHF. Which of the following best describe the impedance of log periodic antenna? Option D is the answer. It is a function of logarithm of frequency. Thank you for listening.